Hello everyone and welcome to session 7 in this data analysis part of our XPS for Beginners course, and today we're going to be looking at some quantification of some of the things that we've been doing so far in terms of putting in regions and components and making peak models. We're now just going to have a look at how we can quantify these, how we can export these, what kind of information we can get out, and how we can get some information out about errors as well, and how we can quantify and display and export all of those. So we will head off to Casa now. And we're going to get started. So these files will be provided for you to play with afterwards as well. You can have a go at what we're doing in this session, and you'll also be able to have a go at a couple of other examples that we will provide for you. So do feel free to get in there, get stuck in and play with those. So we have our sample. So this is PVP, nice and simple. We've just got some carbon, some nitrogen, some oxygen. We've looked at this one already so far in the course. And so straight away, as we've mentioned before, we're just going to load up our library file. And in this case, we are using a Kratos library, so we'll load that up. We've got our element table in there now. So a few of these things we have covered already, but there's no harm in going over them. It is important to remember that you load your library files, otherwise we won't be able to quantify anything, because these have all of our RSF, so our relative sensitivity factors, and depending on the instrument you use, this will be a different library of sensitivity factors. So if we go into the library directory here, we can see we have a Kratos library because these samples were run on a Kratos, and we have a Schofield library, so using Schofield factors, which is the default for thermo instruments, but do check with whoever operates the instrument you've got data from if you've not run them yourself, because you'll need to know which library file you need to use, otherwise your quantifications will not be correct. So there's a couple of ways we can get our peaks in again. We can go to the periodic table, select our CNO, and the spectra will be tagged with those elements there. Or we can go to find peaks, and again this will pick out the peaks here based on the positions of the 1s orbitals and these Augers as well, these KLL Augers. This is a very nice feature. It does kind of break down a little bit when things get a bit more complicated, because it gets trickier to pick out multiple peaks when you've got lots of overlapping things. So you'll probably have to use your common sense a bit in terms of removing things which are probably not in your samples. If it tells you you've got technetium, you probably want to untick that one, but it's a good place to start. So, and what we can do is just click on create regions, and that will give us some atomic percentages out here. So once we've done that, we can go to our quantification window, this window that we use quite a lot here, and we're just gonna zoom in and check. So for peaks such as carbon, oxygen, nitrogen, the software's pretty good at drawing in these regions. We're using a survey scan, so the step size is quite large. Relatively speaking, it's quite large. So we're not going to get perfect backgrounds across there just because of the noise and the fact that we do have a large step size. But they're generally pretty spot on for these, so we don't need to worry too much. So what we can do now is come up to our annotation pane, and this is where we can sort of change things like fonts and change how everything's displayed and make things look a bit nicer. So I'm just going to move this out of the way so you can see the table. Okay, so what I'm going to do first is I'm just going to delete the existing table that it puts in by default, and then we're going to go through it and add our own tables So just so you can go and see the process of how everything's going in. So the first thing we can do is just go to the quantification tab, and we can just leave everything by default and click apply, and that will put in the table as we had before. Again, we're just going to go back and delete this. Now if we want to update things, so we can put in a few extra things that we want to know. So we can, for example, exclude the position, exclude the area. Maybe we want to include the weight percent and apply that. And now we have a table of atomic percent and weight percent nicely calculated simply up there. Now another nice thing we can look at is if we go to text. I'm just going to open up the quantification window as well. Just move this a little. So one of the interesting things you can do with the tag function, so this down here we have tag in our quantification regions. Just going to change these labels to remove the orbital. Then we can close this again. Now back in our text tab, if we go to set formula text from regions and then apply, we can get an automatically derived stoichiometric formula based on the quantification of the sample that we've got. So here we've got C6NO, which is what we would expect from PVP, that is the stoichiometric formula. So that's a really nice way of just getting that up there for you to easily see and see how that changes when you sort of adjust your regions and improve your fits and stuff. So again, anything we put on, we can just come here in annotation history and just delete those. So I'm just going to delete this table as well. So the last thing in this example we're going to look at is regions. So one of the very nice things that we can do in regions is if we just exclude everything we don't want. Oh, we'll include that. We're going to tick include atomic standard deviation and then apply. So at the moment it's reading 0, so we're just going to open our quantification window again. And in the regions tab, what we've got down here is calculate error bars. So if we click that, you'll now see that our standard deviation table has been populated with a calculated error based on the background and the region fit. And so this is how we can produce the error that we want to know. So that's survey scans, and they're a very nice way of quantifying your data and looking at things like that. Oftentimes, particularly if you're looking at trace elements, it can be useful to look at the high resolution scans, which are obviously more typically useful for looking at chemical states. But we're just going to go across and apply some regions across here. Just some very quick and simple ones. And there we go. So we've got our regions here. Just adjust that a little bit. All looking nice and sensible. So if we want to quantify based on our regions, there's a couple of things we can do. Firstly, in the quantification parameters box, there is this report spec tab, and you'll notice under the standard reports there's a button that says regions. If we click on that, just open the region quantification table, and this will give us a nice table with all the information that we could want from this, and then at the end our atomic concentration. And if you come up to this option here where it says copy, you can then copy this, or you can copy a selection to your clipboard, which you can then obviously export into Excel rather easily. So that's one option. which works perfectly fine if you've got a single sample such as this. If you have multiple samples, the easier way to read this out is if you click in Custom Report, go down to Regions, click Regions, and then click Area Report. This will then give us the atomic concentrations of the different elements in columns. So you'll have your samples down in rows and you'll have columns here, which can oftentimes be a lot easier in terms of exporting that into Excel and then tabulating your data in there. So if you're working with lots of data sets or lots of samples in a single file, then I would recommend going to regions and doing the custom report regions and doing it based on the area report there, just for ease of tabulating your data. So one thing we might want to look at in terms of these high resolution reports is, again, looking at the quantification of our errors. So if we come up to our annotation and come to regions, we've got all of our elements selected. So if we click apply, and what you'll notice is we've only got oxygen, because we've only got oxygen active in the tab. So what we need to do for this is, if you come up to overlay, so if you select the overlay function up here with your oxygen, nitrogen and carbon in this case selected, we're going to have to stick these into a single block in order to get our errors out. So I'm going to open up processing, which is F8, and we're going to go to this tab called test data, and down here there's an option called merge irregular. So if I click on that, that's then going to give us the carbon, the nitrogen and the oxygen all in a single VAMAS block. So this is essentially almost like a survey spectrum, but we've cut out the bits that we don't want. So there's nothing in between sort of 410 and 520, and similarly between the carbon and nitrogen, because there's nothing of interest there for us. So this is just reading it as a flat line, but it's put it into a survey type spectrum, but we have this improved step size. So once we've got that in a single block, we can then come back to our annotation, come to regions and apply, come back up to our quantification, calculate error bars, and now we have our standard deviation error for our high resolution scans. So it's a little bit of a workaround, but that's how you can get those into the error format. So just come back to our original file now. Of course, we might not want to just quantify regions. Of course, the components themselves are very important. So I'm just going to stick in. I think we quantified these in a previous demonstration. So I'm just going to put in some very simple fits. It doesn't necessarily matter what we're getting out, as long as we've got the components. So we'll just call these C1, C2 and C3. So straight away you can see down at the bottom we have our percentage concentration, which you can simply read out from that. You can come back up to report spec and use a component report, and this will, we have our C1, C2, C3 in the table, and then our atomic concentrations up there. Or again, if we come down and just clear the previous custom report and add in a component, we can then get those again based in functional groups in columns. So again, if you're working with larger data sets, that can be an easier way of getting those out. For example, if we just put in our other ones, so we've got oxygen 1, nitrogen 1, carbon 1, 2, 3. Just going to add our other components in there. And now again we've got carbon 1, carbon 2, carbon 3, nitrogen 1 and oxygen 1. So as long as you remember to highlight all of the blocks, the VAMAS blocks that you'd like to quantify, they'll all get dragged into this report at the end, and that will give you the overall concentration. So again, if we come up to our components here, we can see that we have about 10% of oxygen, 12% nitrogen, and then the remaining percentage is split between the 3 carbon species. So again, if you want to copy these, come up to the copy function here, copy all to clipboard or copy selection to clipboard, and you can paste those in Excel or whatever program you wish to use to display your quantifications. So that is a summary of how we can quantify our XPS data and how we can report some stuff. So again, there's plenty of files for you to work with and play with, and we will have some worked through examples in the question and answer area below. So do have a go at those, and follow along the videos if you'd like to check that what you're doing is good. And yeah, so just in summary, the elemental reports you can obtain from wide scans and region scans, and there are also component reports that will quantify the chemical states in your system as well. And of course, we have our stoichiometric formulas that we can get up using those tag functions as well. So our next and final session in this intro to data analysis part of our course is going to focus on exporting data, so normalizing and display parameters as well, and that's going to be introduced to you by Professor Phil Davies from Cardiff. So thank you, and we'll see you in the next session.